Alright, sections 10-1 and 10-2 are a review of a lot of the ideas you've heard about in previous math classes on areas. Okay, we'll talk about areas of rectangles, parallelograms, triangles, trapezoids, rhombi, and kites. Okay, and by the end of this video, you should be able to find the area of rectangles, parallelograms, triangles, trapezoids, rhombi, and kites, and also identify the altitude and the base or bases of these same shapes. Okay, the area of a rectangle, as you probably know, is base times the height. And the area of a parallelogram, which is, you could think of it as a rectangle kind of that's slanted, is also base times height. Okay, one important thing to note is that the base of a parallelogram can be any one of the sides. Okay, the important thing is the altitude, the segment we get the height from, is perpendicular to the base. Okay, so like on number 1, now there isn't a bottom one because the base doesn't have to be on the bottom, but looking perpendicular to this red line, which is the altitude, these two sides are the base, are bases. Okay, number 2, this right here is the height of the altitude, so the base must be the top and the bottom. Okay, 3, if I asked you what the bases were, you couldn't tell me until I told you where the altitude was. And if I drew in this as the altitude, you would then say, well, it's perpendicular to the altitude, so these two sides must be bases. Okay, the base is perpendicular to the altitude. Okay, a few examples. In A, the base is 5. That's easy enough. The altitude, or the height, is found perpendicular to the base, so it must be 4. Okay, so the area is the base times the height, or 5 inches times 4 inches, and you get 20 square inches, or inches squared. Okay, I'm going to skip B. C, to find the value of h for each parallelogram. Okay, we will first find the area of the parallelogram using 2 dimensions that we know, meaning I know the base of 14 and I know the height of 8. So I can use those to find the area of the parallelogram. The area is base times height, or 14 times 8, which is 112. Okay, and I'll use the combination that I don't know, this 10 and the height of h, but the area is still 112, and so the area is base times height, so 112 is equal to the base of 10 times the height that we don't know. So I'll divide both sides of this equation by 10 and get that the height, or h, is equal to 12.2. Okay, so what we first do is find the area of the parallelogram and then use that area and the base that we know to find the height. Okay, the area of a triangle is half the area of a parallelogram. Okay, so the area is 1/2 the base times the height, which I'm sure you already know. A base of a triangle can be any one of the sides. Again, the important thing is the altitude is perpendicular to that base. Okay, just 2 examples. A, the base in this one is 16, so the area is 1/2 the base, 16 centimeters. Times the height of 12 centimeters, and so 16 times 12 divided by 2 is 96 square centimeters. Okay, B is similar, so I'll skip that one. C, if you're looking for the height right here, you won't find it because that height's not right there. But if you notice that these two sides are perpendicular, they're 90 degrees, then one of them you could think of as the base and the other one as the height. Okay, so the area will be 1/2 the base of 4.5 yards and the height of 6 yards. And so 4.5 times 6 divided by 2 is 13.5 yards. square yards. Okay, 10-2 begins with trapezoids. Again, remember that the bases are the two parallel sides, and the height of the trapezoid is perpendicular to the bases. Okay, the textbook uses this equation. The area is 1/2 the height times the sum of the bases, which may be easier to compute. But the way I think of it is I think of it as the average of the bases. Now, if you find the average of two lengths, you find the length that's right in the middle. Okay? So this is the same area as a rectangle with the base of the average of B1 and B2 and the height of H. Okay? Now the way you find the average of two numbers is you add them together and divide by 2. So B1 plus B2 over 2 times the height. Okay? Now this is the formula that I prefer because I think it's easier to remember, not because it's easier to compute. Okay, so one example, the approximate area of Nevada. Okay, again, the area is the average of the bases times the height. Okay, the bases are the two parallel sides, so it's 205 plus 511 over 2 times the height of 309. Okay, 205 plus 511 divided by 2 is 358 miles times the height of 309, and I get 110,622 square miles. Okay, the last idea is the area of a rhombus or a kite. Okay, it's 1/2 the product of the diagonals. Okay, so I have a rhombus drawn out down here, and so the area is 1/2. Now the first diagonal, this one, 4 plus 4 is 8, and this diagonal is 14. Okay, so 1/2, 8 times 14 is 56. Okay, so the area of this rhombus is 56. All right, a couple of examples using that formula. This length right here is 3. Okay, but I don't know this length down here. If you think about a rhombus, the diagonals bisect each other. Okay, so this must also be 3 down here. And for the same reason, this is 5. This is also 5 down here. Okay, so the formula is the area is 1/2 times the product of the diagonals. So this diagonal is 6 feet, and this diagonal is 10 feet. And so 1/2 of 6 times 10 is 30 square feet. Okay, similarly for a kite, number 3, this diagonal is 20, and this diagonal is 30, and so the area is 1/2 20 times 30, which is equal to 300 square meters. Okay, in summary, the area of a rectangle is the base times the height, just like the area of a parallelogram, which is base times height. Okay, the area of a triangle is 1/2 base times height. The area of a trapezoid is 1/2 the height times the sum of the bases, or the way I think of it as the average of the bases times the height. And the area of a rhombus, which is 1/2 diagonal 1 times diagonal 2, and the area of a kite is 1/2 the diagonal 1 times diagonal 2. Okay, in this video we talked about the areas of rectangles, parallelograms, triangles, trapezoids, rhombi, and kites, and also how to identify the altitudes and bases of these shapes.